We are here to discuss computer vision. We are going to see what computer vision is and how it is applicable to current industries and our daily life. I'm going to discuss some applications in different sectors with you, and I think it would be beneficial to discuss what exactly we can do using computer vision, which questions can we answer, and how does the computer vision works exactly. And we are going to discuss some methods we can use in order to build our computer vision applications. And after that, I will introduce you to state of art techniques or the current techniques that we are using right now in computer vision. And these applications, these techniques, they are used by some big tech companies like Google, Amazon, who are involved in building computer vision applications. But I would like to emphasize at this point that this is only a brief introduction and it's not a tutorial on these techniques. I will introduce you, I will tell you what those techniques are, what it means, and even that is very important when you start looking at computer vision, because these techniques, they are currently being used, and even if you don't know how they exactly work, you should be able to at least know what they are used for. So after that, we will discuss about Google Lens as a case study. We will look at Google and its applications and what techniques that it has used and it is using in its current applications. We will see that uh, Google Lens uses a lot of computer vision techniques. And even though it is only 3 years old, it is still coming up with new updates to make it more precise and user friendly. And after that, maybe we can discuss some current market trends in India. And I will share with you some very interesting statistics and from a recent research report. And we will discuss uh, things related to jobs in this field. For example, what kind of experience level usually people have, and what kind of knowledge domain you should be having, what kind of salary can you expect. And I will share with you some statistics related to these. We can also see what companies are currently hiring for computer vision engineers and most likely recruit some more computer vision engineers in future. First of all, maybe you would like to know what is computer vision. Let's see. Computer vision works how our human vision works, like on a similar level, to capture the light and receptors in our brain to access it, and we have a visual cortex in our brain to process the data that we see. Similarly, using computer vision, what we're trying to do is replicate a human. We have using our computers. So we have different cameras to capture the light. Like we have monocular cameras, stereo vision, we have some RGBD cameras, we have thermal imaging. We have so many resources at our possession to capture the light, but actually this is the easy part of the computer vision. The understanding what's there in the photo is much more difficult. And when we hear someone say image processing or computer vision, we might think that they are the same, but in fact, these things are very different in some sense. Like image processing is just looking at an image in terms of raw data where we have some pixel value, and for each pixel, we may have some intensities across the color spectrum, but there is no context there. For example, let's take an example of an image with the sun. So when we look at the image with an image processing perspective, we can see that there is a sky which is blue color and there is a sun which is yellow color. We can see that the sun is round. We can see the color pigments. We can see that the sun is yellow color, or maybe some light yellow shade, and we can see the sky. It may have some clouds, it may not have some clouds. So we can only see, but what we cannot say that this is a cloud or this is a sun just by looking at the images. What image processing does is it tells you that there is an image that has a round circle which is yellow colored and the background is blue color, but it will not tell you that that image is a sun, or that blue background it is the sky, or it will not tell you that there is the white noise in the background could be a cloud. So we use computer vision to tell us the context. It can tell us that this is a picture of landscape with some clouds in it, with some sun in it, and this part of telling you and that the picture consists of sun is applying context. And this is what computer vision is. It looks at an image and it tells you the content of it. These images can be from photographs, can be from videos, they can be from anywhere, and we use image processing in it to apply some kind of image enhancing filters or some signal processing to help a computer figure out what is the context of the image. That is computer vision. So the first part is actually called pre-processing, and computer vision uses image processing to accomplish this goal. And I hope now you know the basic difference between computer vision and image processing. And now we have a question that what can we do with image processing? What can we do when we give our computer this power to apply computer vision? What problems can we solve? To answer these questions, now we are going to look at some applications, and I hope after that you will understand why computer vision is important for you. We can use computer vision in retail industry. For example, here in Germany, where I am, it's used in some big shopping centers like IKEA. We can go to some self checkout counters where we can ourselves scan our codes of different products that we are buying, and then we can pay using our bank cards all by ourselves. We don't need a cashier, and this could be applied to Indian supermarkets also and malls in future. We can have some facial recognition systems also that could be helpful, and in fact they are proven helpful to retailers when they are detecting some kind of suspicious activity, like if someone is trying to shoplift or if someone is trying to steal from your store. Using your computer vision systems, you can just alert the store managers, you can alert the security, and it can potentially help the retailers to understand where are the drawbacks in their security systems so they can improve. If we think about it, there is some other applications that retailers can develop from that they can use from computer vision. We can, by using some kind of recognition systems, we can retailers can understand their demographics, what kind of people visiting their stores, what kind of stuff they're buying. They can decide on the behavior of their customers, and this is useful because it can optimize marketing and their sales also. So they can apply it in sales, and we can also actually apply it in this pandemic situation. We can use some kind of computer vision applications to monitor that the customers are maintaining social distancing in the store, and we can check their mask compliance, that if they're wearing masks or not. Although currently we are not using it, but it's a good idea. Some of us who are interested in computer vision can implement this idea into some applications later on. Currently, we actually, the thing that we are using is temperature screening. We can use thermal image in stores or to check if the customer that is coming in has a fever or not. It would be really helpful in the current situation. And not only in the retail industry or in the stores or in the supermarket, we can also use this thermal imaging to predict the temperature of a person to some airports or some other public spaces. Then we have manufacturing sector. In manufacturing sector, computer vision has seamlessly become a part of smart factories, as it increases efficiency as well as accuracy. For not just the it doesn't just increase the digital performance, but I think it also increases the human performance. When we are working in a factory with machines constantly, sometimes they can broke down, they can have some malfunction in their equipments because they're constantly running. There may not be repairs or maintenance going on because of constant use. So using computer vision, what we can do in manufacturing industries is to do a predictive maintenance. So by predictive maintenance, I mean that we can predict when the machine needs maintenance. For example, we can change the bearings, we can change the oil of the machine. It actually saves a lot of effort and it saves a lot of time. So we can do a predictive maintenance. We can, using computer vision, we can predict when our machines require some maintenance. And so we don't have to observe the breakdown of machine. Before it happens, we can just go and change the bearings or the oil, and we can save a lot of time, a lot of effort. We can use computer vision while doing package inspection, for example, at a manufacturing industry. After we manufacture products, we do some packaging and then we ship the products. So while we are doing the packaging, we can also do an inspection using computer vision. We can remove the products that are defective and we can count the products. For example, an England based pharma company uses this technique to count the tablets before packaging. And it can be also used to strictly implement the packaging rules. In the pharma sector, sometimes the packaging rules are very strict. Where should they place the seal? Where should they place the labels? Where should they place the barcodes? Because whenever you're buying a medicine, it should have the vital information on it, and it should be easily readable. It should be user friendly, so that we can look at a bottle with some medicine and tell what kind of medicine it is and what are its ingredients and other stuff. So it's actually helpful to not just to manufacturing sector but also to pharma companies, so that they can use this computer vision techniques to apply and implement these packaging rules strictly. And I think most of you know that computer vision is most popular and widely known for its applications in medical field. And actually it is currently helping doctors across the world to diagnose their patients better, and they can monitor the evolution of disease. Again, we can take the current example, this pandemic of coronavirus. Lot of companies, they are using some kind of computer vision techniques to diagnose their patients and to prescribe a treatment. And it is used to increase our efficiency and save a lot of time for doctors on routine tasks. And which will help the doctors to spend more time with their patients and less time on the things that can be digitalized. It's very helpful in the medical field, and not only in diagnosing and prescribing. We can also use computer vision techniques in analyzing radiology images and like MRI scans to maybe predict some cancerous cells or tumors or anything. Use these computer vision techniques in healthcare systems, and we can also do some kind of monitoring using computer vision. We Some other applications of using computer vision in medical field could be like we are doing performing when doctors are performing some surgery, there is some blood loss. So using computer vision we can actually accurately say that how much the blood has been lost, or when a person is in has suffered an accident, we can using computer vision applications we can measure the blood loss accurately, more with more accuracy than a human can do. Using these computer vision applications we can also detect some early onset symptoms for some diseases with more accuracy, like some cancer or tumors, or like even some diseases, neurological diseases like Parkinson's. When Like I would give you an example. When a person is suffering from Parkinson's, they have a problem with their gait, tremors in their hands, which could be taken as a sign of old age, because these symptoms people experience them when they are old, and they could be people could simply label them that that person is getting old, that's why they're experiencing these problems with their gait, or their motor skills are losing because of the age. But they can miss that that person could be suffering from a disease. By using computer vision we can analyze people who are suffering from Parkinson's or any other disease, and we can correctly diagnose them and their symptoms, not only in their later stages of life, but also in the early stages. Suppose when they are in 30s or 40s. There are some other applications for computer vision too, apart from retail, manufacturing, and medical. There are actually a lot of applications. I'm discussing these with you, but that doesn't mean that there are limited to these applications. There are more than this, and there can be a lot more. It's a very new topic to think about, and especially in India we don't have so many companies who are working in this field, so we are still in the very early developing stage for regarding computer vision. So that's why we can have a lot more applications than these. Talking about government sector, we have solutions that would benefit government sectors. Some computer vision applications for safety and surveillance. For example, in China, in Russia, government uses surveillance. They could be, of course, used for negative things too, but mostly it's used to keep everything and everyone safe. For example, this year when the pandemic started, the government in Moscow, they used the surveillance systems to track the people who were breaking like the quarantine period, and like tracking people who are breaking these quarantines, so that they can make the lives of other people better, making them safe. And yeah, so and apart from the surveillance and safety activities, we can use computer vision to make our city smarter And by that I mean we can control the traffic on roads, and in public sector we can use computer vision to better understand physical condition of some assets that are under the control of government. It could be anything. It could be an equipment, it could be an infrastructure, like we can monitor some infrastructure and some, there are some heritage building that are very old and they need some kind of maintenance from time to time before they collapse maybe, or before they break down. We can do a maintenance for them using computer vision. We can predict about their physical condition when they're going to collapse. What can we do to prevent them? Then we can make some plans about what we should do to prevent that from happening. And it can also be used to detect some kind of contrabands in cargo. And currently, a lot of drones are being used in defense and homeland security. Even the government sector has a lot of potential for using computer vision applications. And now coming to insurance sectors, the companies use computer vision to conduct consistent and accurate vehicle damage assessments. By that, I mean that suppose we have an accident and insurance company has to assess whether that accident is real, how much damage the both parties have, how much money should go to, for example, the party for their car insurance, for their vehicle insurance. These computer vision applications, they make this process easier by because we can reduce some kind of frauds, and we can also streamline this claiming process, claiming for insurance. We can make it easier using computer vision because it would efficiently detect the damage is consistent with the accident, if it was a genuine accident, or if it's just for the fraud activity. In fact, some companies use computer vision not only to do this but also to verify the documents. They can run some facial recognition systems for their customers whenever it is required, for example, to verify a passport, a driving license, or some other ID cards, anything, your Aadhaar card, even. Like they can do it. And here in Germany, they are in banking systems. It's used to, for example, open an account online. You fill your application online and then you send a photo of your passport, send a live photo of your passport with your face in it. So their systems can use computer vision applications to verify that this passport in fact belongs to you. We can implement similar applications in India too in future, maybe. In some startups are also working in this direction. So we can expect that these applications will soon be available in India too. So computer vision is essential in developing some unmanned robots and unmanned vehicles in robotics. It's an essential part of developing any robot that is unmanned. And it is currently also being used in developing driverless cars. So we have seen Waymo, which is the Google car. Everybody must have at least heard about it or maybe saw it on YouTube. So Waymo, it uses computer vision to navigate safely through traffic and detects temporary road signs, give way to emergency vehicles like ambulance, a police car. These things they're very difficult for computer to do. We humans can do it so efficiently because we have a lot of evolutionary advantage over the machines. We have our eyes that are maybe not as perfect sensors as the cameras that are available in this age, but they are pretty good. And our brain is amazing. We can like look at things and compute their depth, or at least assess that, especially the r we can see that temporal existence, like over time, if the chair is here, after some time it moves to there, we can, it's nothing, we just do it in the blink of an eye. But for a computer to do these simple applications, it needs a lot of programming, a lot of efforts. And in this presentation, in this webinar, I will tell you about some techniques that currently are being used to implement all these applications in useful things to make our lives better. Coming back to this slide, we have agriculture sector is in fact the proof the how useful these computer vision techniques are to us, because in agriculture sector we can have some drones to monitor our crops. We can have not only the drones to monitor our crops, we can have some kind of monitoring system to see the yield of our crops. We can see if there is some kind of infestation going on, and we can prevent that from happening. If something, an infestation is happening or it's ruining the fields, we can use our computer vision to prevent, to take some, to prepare ourselves better in that kind of situation.